used Z. The Z is X minus mu by sigma. But in real world, I don't know the mu and sigma. I can calculate for a sample. This is for population. I can calculate the Z for sample also. Sample. But still I am representing, if this is X, I am keeping here X, ZX. Okay. If I am using a X here, I am keeping the X. I may use something else also here. You guys are understanding what I am saying? What is the Z business? Let us understand. If X is normal, if X is normal with mu and sigma square as parameters, very, very important statement which I am going to write. Parameters. Z also, Z follows normal with 0 as a mean and 1 as a standard deviation. I mean the variance. Very, very important. If X follows the normal. If X is not following the normal, X is not normal, okay. If X is not normal, but for any data you can calculate the mu and sigma square. But we can calculate. This is very, very powerful statement which I am writing. It is going to drive the entire course. But we can calculate mu and sigma square for any data. For any data, we can calculate, and we can calculate Z. This Z is not normal, but it is, instead of it, Z is going to have, not going to be, going to have mean 0, standard deviation 1. Very, very important statement which I have written. Most of the people confuse here. Let me explain what I have written. Let's say I explained a crude method of looking at the given data is normal or not, right? How to? Let us see. This is my data. This I'm calling as a X. Like, you know, whatever the data, some data is there. Okay. It could be number of pens each person is having, number of rupees each person is having, any data, it doesn't matter. Okay. Now, what I'm going to do, let me take this so that you guys understand clearly. Let me do it in Excel. This is my X. Okay. Now, I can calculate. Do you know this follows the normal or not? How can I verify? I'll go here. Simple way I'm saying, this is not the scientific method. We are going to learn the scientific method afterwards. X. It looks like a normal. I'm confused whether it is normal or not. So I'll go to the box plot because there are only few observations are there, around 100. Yeah, it is looking like a normal, right? You guys are understanding? If you have a confusion, you do the with what is that histogram as well as the box plot both. Yeah, it looks like a normal. So now I'm taking this. It is going to have some kind of mean and standard deviation. What is the mean and standard deviation of this data? I'll go here, basic statistics. I look at this. Mean is 3.04. What is the standard deviation? 1.524. Let me calculate here. So I'm calculating again mean, assuming this is a population or sample, it doesn't matter. Mean, assume there is a population or sample, it doesn't matter. If a population, then that will become a mu and sigma. If it is a sample, that will become a X bar and S. There is not much difference. You guys understood this point? Okay. Now I'm calculating the very, very important thing which I'm doing. Mean equal to this much. What is the standard deviation sigma? Sigma equal to STD. Yeah, is a sample or population? Let's assume a population. Okay, this is what it is. Now what I'm going to calculate, Z. Z is what formula? First, to calculate the Z, I need X minus mu, right? Yes or no? What is the meaning of this? Or if you guys confuse, most of the times we are going to deal with sample. Let me write as a sample. This is yes. So here this is the dot S. This is fine. Like this also I can do. You guys are understanding what I'm saying? Okay. Or if you want to know the sigma, let's keep the sigma. Because I'm talking the theory. Whenever we talk the theory, we will consider, I know the population. Theory, na? You guys are understanding what I'm saying? In the real world, you might not be having the population. Definitely you are not going to have a population, you are going to deal with sample. Okay. It doesn't matter. So I'm taking this. Let me write as a X bar here. X bar. Okay. Now what I'm going to do, I'm going to calculate this minus X bar. This is a constant across. So I'm making the constant. How to make the constant? I think F4. Yeah. So I'm drawing down. Oh, this is not highlighting. It's a problem for me. Okay. This is what it is, X minus X bar. But we know X minus, what is the sigma? Sum of X minus X bar is how much? Let's look at sum of all these things. We know from the theory, it's near to 0. How this is? Minus 8.8 into 10 to the power of minus 16. So if I convert this into only the 2 decimals, 0. You guys are understanding? Sigma X minus X bar for any data is 0. Now let's calculate the Z. What is the Z? This Z equal to this divided by S. M&D. This S is a constant for given data. So I need to divide that this value by S always. So what I'm trying to say is take this and divide again. Take this and divide again. So I'm going to copy this again. This one. Now, what is the sum of all these? Let's calculate the average for Z. Let's calculate the average for Z. Anyway, numerator is 0. The numerator is 0 or not? X minus x bar is 0, no? So what I'm saying is, let's calculate the sum of average of z. First, to calculate the average, what I need to do? I need to sum in the numerator divided by number of observations. So sum of z values. Sum of z values. How much it is? Again, this is 0. This is, what is the meaning of this? Minus 4.5 in 10 to the power of minus 15. 10 to the power of minus 15 means what? 0.00, 14 zeros and whatever it is. You guys are understanding? E minus 15 means what? 10 to the power of minus 15. Very, very small value. So it is near to 0. Why? I'm not getting the exact 0 because here I'm not keeping all the decimals, right? It is a, you guys are understanding why? What? Right. So this is going to be 0. So when the sum is 0, average also will become 0. The numerator sum is 0. What is the formula for average? Sigma x by n. When the sigma x by n, the sum of the numerator is 0, definitely again the average also will become 0. So what is this? Sum of z value is 0 means average of E of, average is nothing, can I write like this? Average of z in a notation. This is also 0. You guys are understanding what I'm saying? How much is this? Let's verify if you want. Average of all these values. Agreed? M and D. This is also near to 0 if I clear. Let's calculate the standard deviation. Let's calculate the standard deviation of what? Z. That is nothing but the variance of Z. If I know the variance of Z, I can calculate the standard deviation from it. Variance of Z equal to sigma square. If I can calculate the sigma square value, I can calculate the sigma in eta. So let's calculate the sigma square. Variance of Z. Variance of, say, as I call this is a variance, I'm calling this a dot P. When you're having the data too much, it doesn't matter whether I take the dot S or dot P. But here 100 observations, let's take near to 1. Why it is coming near to 1? There's some kind of approximation is there, right? But if I convert this into how much is this? Agree? Happy? So variance of for this Z, what happened? The variance will become the 1 and standard mean will become 0. All are with me? You take any data. Doesn't matter whether this follows the normal or not, it doesn't matter. All are with me what I said? So let us take some data which is not normal. Let us verify. I'm calling this also again x only. This is also some x. Let us look at the picture whether it is following the normal or not. It is not normal, sure, right? It is a positively skewed. Agreed, guys? You can verify with this with the box plot also. It is definitely not normal. You guys are understanding what I'm saying, guys? Friends, all are with me. So now I'll take this data and copy there. I'm copying here. Copy. my God. Okay. I kept the calculation as it. Still I am getting, is this x follows the normal? No. Still I am getting, what is this? All are with me, 0 and 1 only. So it doesn't matter whether x follows the normal or not. If I calculate the z value and calculate the average of those values, what is my average will become 0 always for any data. And standard deviation will become 1 for any data. It doesn't matter. But if x follows the normal, z also follows the normal. What I'm saying is, if x follows the normal, z also follows the normal. If x is not following the normal, z is not following the normal. All are with me? So that's what I've written. If x is not normal, but we can calculate the mu and sigma square for any data, we can calculate the z, right? And this z is not normal, but z is going to have a mean 0 and standard deviation. If x is normal with mu and sigma square, z also is going to be normal with mean 0 and standard deviation. If this is clear to everyone, friends online, please respond. This is very, very important property which you are going to use left and right. Nobody is responding. You guys are clear or not? Please respond. This is very, 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 very important. So far you guys understood something or not, I don't care. But this thing, whatever I discussed for last 10 minutes or 15 minutes, you should understand. Okay. Now, let us verify if this is following the normal or not. So I am taking the z value here. I am copying here. I am taking the z value, friends. Let us verify. Why you need to trust my statement? You can verify, right? In both the cases, we are going to get the mean 0. Let us see. I am doing this for z now. Okay. Same as, you guys understood? Same as x only. This is for, this is for what? This is the distribution. Let us verify C2. C2 is some data, that's all. But that is not normal, right? So this is a C2 I'm taking. Things are not changed. You guys are understanding? Distribution is not changed by calculating the z value. I'm plotting it. Why I'm doing all these things, you'll come to know soon. You guys understood this? So she asked why it will become, Samana, why it is always 0 and 1. Let us verify that. Proof. E of z is always 0. V of z is always 1. Why? Proof. I'm doing the proof. Let us look at it. What is the E of z? E of z equals to, can I write E of x minus mu by sigma? The sigma is a constant for any given data because it's a parameter. Mu also a parameter, and sigma also parameter. You guys are understanding? For population, sigma and mu are constants. So can I, if, what is this formula? Ax equal to what? Can I take this A out and E of x? Agreed or not? So can I take this sigma out? You guys are understanding? Okay. 1 by sigma out and e power x minus mu. Can I multiply this e inside? Because e of x plus y equal to e of x plus e of y. Agreed? And this equivalent to 1 by sigma. What is this? mu. Fx is mu, right? We learned so many times, we use so many times. And this is E of mu is how much? Again mu, because it's a constant. How much is this? Clear? Clear? Is this is clear? Who asked this? Rupa. What about this? Variance of Z. Variance of x minus mu by sigma, which is equivalent to when, what is the formula? Variance of Ax equal to A square into variance of x. This is a formula. Already we proved everything we have done. Don't ask me now how this is. Okay, this sigma will come out when it is coming, because it's a constant. Why it's a constant? It's a population value, sigma. When it is a population value, irrespective of the distribution, you calculate, I calculate, everyone is going to get the same answer, no? See, if I taken the calculation, calculated the average, I'm going to get to the same value. Here also, if you collect, you also collect the entire population, you are also going to get the same value. That's why this is a constant. For a given population, mu and sigma are constant. That's what I'm saying. Is the point is clear? Okay. Now, you take out the sigma out. This will become like this. Sigma square V of x minus mu. Again, 1 by sigma square. Can I multiply this inside? Plus, because here plus or minus, it is going to be plus only. You guys remember? But there is no covariance term. Why there is no covariance term? That will become 0. For any constant x, it doesn't matter. It doesn't matter whatever the constant value. My x is going to change the same way. There is no correlation, right? What is the covariance of some x and some constant? It is 0. Why? Irrespective of x value, is it going to change my a value? So there is no change. You guys are understanding? So that's why covariance of x comma a, where a is some constant, x is a variable, is always 0. Clear or not? So that's why the covariance term is not there. Only I am going to have variance of x plus variance of mu. This is 1 by sigma square. What is this variance of x? Sigma square plus 0. Why 0? Variance of mu is a constant, so it will become 0. So sigma square by sigma square, how much is this? This. What? Clear? Clear? So irrespective of x follows the normal or not, I am going to, you calculate the z, calculate the its mean is always 0 and standard deviation is always 1. All with me? So what I am writing is, now if x follows the normal, in simple English, simple notation, if it's very, very important. If x follows the normal with some mean and then z also follows the normal with 0 and 1. If x is not following the normal, not following the normal with mu and sigma square, but still z is not following the normal, but still it is going to have a 0. All are with me? This is a statement you need to remember. Very, 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 very important. Important. Most of the people on the earth, they think that z is always follow the normal. That is not true. Z need not follow the normal. Calculating the z value, calculating the z value is called a standardization. If x follows the normal, x follows standardization. Let me write it as x is any distribution. Okay, so I need this standardization. Why it is called a standardization? Because it is always going to have mean as 0 and standard deviation as 1, irrespective of the data. You guys are understanding? So tomorrow if I say standardize the data, what is the meaning of this? What is the meaning of this? Take x values, calculate the x minus mu by sigma. The new data is called standardized data. What is the meaning of that? So this data is standardized data. All are with me? What is the importance of the standardization? Let me talk now itself. Importance of standardization. This what you are going to do in the machine learning. They call that as a something like normalization. It's not the normalization, it's the standardization. Normalization is the different. Okay? Normalization is different, we'll talk at the time. But this is called only standardization, not the normalization. All are with me? Yeah. Importance. What is the importance of this? If X is having any physical units, X is any physical quantity, I should write like that, but for your consumption I am writing like this. Physical units means what? X can be centimeters, X can be meters, X can be kgs, it doesn't matter. Z is unitless. If X is having any physical units, but Z is unitless. Why it is a unitless? Let us see. What is a Z? For any distribution, it doesn't matter. X minus mu is going to have what units? 0 units, right? Huh? X minus is a 0 units. Huh? In the game is Sadulu. X minus mu is a 0 units. If X is in 10 centimeters minus 2 centimeters, the answer is 8 centimeters or something else. So X is in some physical quantity, like maybe in centimeters. I am subtracting from that some another centimeters. What I am going to get? Some units, some quantity which is having what units? Centimeters only. It is not 0 units. If you subtract something from something, you are going to get some numerical value having the same units, not 0 units. All are with me? You guys are understanding what I'm saying? So the numerator is going to have, let's say this X is in centimeters, the numerator is also going to have what kind of units? Centimeters. And what are the units for my sigma? Again centimeters. Why? Let us look at what is the formula? X minus mu whole square by n. This is good. X minus mu. X minus mu is a centimeter minus centimeter. Centimeter square divided by some number. Root of centimeter square. Again it is a centimeter. When it comes out of the root. Yes or no? So sigma and mu is going to have the same units. If X is in kgs, my sigma also in kgs. So centimeter by centimeter getting cancelled. This is a unitless. All are with me? So my data is not going to have any units if I standardize the data. Very, very important. If X follows the normal, still it is a unitless. If X is not following the normal, still it is a unitless. Z is always a unitless. All are with me? That's why it is a standardizing. No units, always it is going to have mean as 0 and standard deviation as 1. Very, 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 very important property. All clear? All clear, guys? Z is a correlation coefficient. Why it is a correlation coefficient? What is the correlation coefficient formula? Covariance of x comma y divided by variance of x and variance of y, right? Acha, correlation has no units, so everything on the earth which is not having become a correlation. You thought, you think properly. Okay? You guys are understanding? correlation is different, Z value is different. On the earth, there are so many quantities which are not having any units. If you look at the vapor density, is it having a units? Oh, vapor density we have not heard. Huh? Right? But you became an engineer. Okay? So what I'm trying to say, Z is some quantity which is not having any units. Okay? If Z doesn't follow the normal, the Z may or may not. If Z follows the X follows the normal, Z also follows the normal. If X is not following the normal, Z also not following the normal. As simple as that. If X follows the normal, Z is not following the normal, that statement is not right. Okay? If X follows the normal, for sure, Z also follows the normal. All are with me? But only the standard deviation mean is going to change. All clear? If X follows the normal with a mean, if X follows the normal with a mean mu and sigma square, my Z follows the normal with 0 and 1. This is the property. All are with me? Any question, guys? Okay. Now this is very, very important. Why I taught this? Let's understand now. Now for some data, when X is following the normal, I'm taking now going forward, X is following the normal. If X is not following the normal, we'll deal that in a different context. But for the time being, maybe this entire week, when I'm saying X, it follows the normal. All are with me? I mentioned explicitly if X is not following the normal. You guys are clear? So whenever I'm saying, so let me write it. X follows normal with mu and sigma square. What is the meaning of this? If I draw the picture, here the X values. I draw some histogram. It is going to have some probability density function. Yes or no? Now this is going to be a mu. What is the sigma? Sigma is going to be the spread of the data, right? We'll see what is the meaning of the spread of the data and all. Okay, mean is this, and this what my data. So this is going to have a, I'll write like this, sigma square. All with me. Mean is the center, sigma square, it is the data is having the variance of sigma square or standard deviation of X. But most of the times we don't represent here standard deviation, we always represent with a sigma square. All are with me? All are with me? No question? Okay. Now, let's say I want to find out the area from here to here. Let's say this is X. Let's say we have taken that Modi's problem, high data, right? So let's say this is a 170 centimeters. So let's say this is a 180 centimeters. I want to find out in the entire this distribution how many people are there in my entire population between 170 to, let's say this is a standard deviation of, let's say sigma equal to, let's say some 10. How much is this? Let me show the data. How that? Don't look at what I'm doing so that Dekho, this is the height data. How many observations I collected? Huh? Some 10,000, huh? I don't know, whatever it is. So let's say this is a height. This is like my X. Before, this is like my X, right? Let us study the graph of this. Is there a name for Z? No. People call Z score and all. So can I assume this is the normal? Can I assume this is the normal? If someone asks me, tell me what are the parameters, calculate the mean and standard deviation. So let me do that. So I should write what? Height should fall in the normal with 169.96. Can I take as a 170 for our consumption? Comma, what is the sigma square? 9.97. So can I take this as a 10 standard deviation? So 10 square. You guys understood? But if h is not following the normal, can I write like this? I cannot. Because this h, what is this notation? H following the normal. Now I'm asking a question. When this is having the parameters like this, I want to know in the, it is like this, the graph. 170 because this is a mean. Yes or no? This is a mean, nah? So this is how much? Let's say 180. I want to understand or 175. I want to understand what is this area. What is this area? Strictly speaking, how should I solve this problem? We open, Gopal, close your mic. Strictly speaking, how should I solve this problem? I want to find out this, right? This is nothing but, in the last class, people who are not understanding, they can ignore this. 170 to 175. I want to find out the what? F of x. What is the f of x? 1 by sigma root 2 pi. What is the sigma here? 10 root 2 pi e power minus of x. X is a x only, minus mu 170 by 10 whole square dx. This is what I need to do. But statisticians, what they have done, no, don't do that. I'll give a shortcut. Because statisticians are not expecting you to know the integration. Along with me. So this is a high data, right? If some weight data is there, let's say, at the time, this and this is going to change, right? The rest of the story is same. Along with me, what I'm saying. From height, weight, age, if the data follows the normal, this is what I need to do. So what they have done, don't worry, I will standardize the data, because when I'm doing the standardization, it doesn't matter, you collect the height or weight or whatever it is going to have mean as 0 and standard deviation as 1. Yes or no? And calculate the corresponding Z values. So what I'm trying to say, what is the Z value? The area. What is the Z value for this 170? 0. Why? Why it is 0? This corresponding 170. Let me call this value as a Z1 and let me call this as a Z2. What I'm trying to say is, I'm transforming this data to something else. Let me give a story so that you connect what I'm saying. It is like this. You went to some horoscope person, some pujari, pandit. Okay, you want to know your horoscope. Okay, you want to know your horoscope. So you went to him. What is going to ask you? Your date of birth, place of birth, all those things. Why he is going to ask? Because he is going to have some book in his pocket, in his bag. He wants to convert your data into his own language. Whomever they go to him, what is going to do? He is going to convert everybody's data into that horoscope table data. You guys are understanding? You might have born in August, someone else in September, someone is in 1970 October. It doesn't matter for him, right? Whenever you go to him, whichever the time, he is going to convert everything into the language which he knows. You guys understood? So similarly here also, our horoscope table is what? Based on the Z values. So what is the meaning of this? For any data, I can calculate my Z values. Yes or no? You give height data, I can convert that data into Z. You give weight data, I can convert that into the Z. So what I'm trying to say, irrespective of your date of birth, time of birth and all, is going to convert into his horoscope table. In the future, you give whatever the data, I'm going to convert into Z values, because irrespective of the data, it is always going to have mean as 0, standard deviation as 1. I understand this data very well than your different quantities. What is the meaning of the different quantities? Like height, weight, age, temperature, pressure, I don't care. Because when I convert those into my Z values, those are unitless. All are with me. All are with me. The way horoscope person is changing, converting your data birth into his known language, I am also going to convert. You give any X value. It could be height, weight, I don't care. I convert into that into my Z value. I'm going to do the analysis on Z. All are with me? All are with me, guys? All are with me what I said. So what I'm trying to say is, now I want to find out the area between 170 to 175. Or not only that, let me explain. So whatever I said, let me put it in some X value is there with some mean and some standard deviation sigma square. I'm converting this into what? I'm assuming X follows the normal, okay? Z also follows the normal. Is the graph is going to change much? We have seen just before. When I convert X into Z, did the histogram change? No. So graph is not going to change. That's what I'm saying. Okay? But only what it is going to change. This is 0 and sigma square equal to 1. Here, this time, the scale will become the Z values, right? Not the X values. Here, X values. This is called transformation. No need to write anything. Transformation. What is the transformation process is called? Standardization. You guys understood what I've done, guys? You guys understood what I've done? Friends, so let's take this height data. This height data, I can calculate the Z value. So Minitab, Excel is going to give a facility, standardize the data. Okay, look at this, standardize the data. So what is that? I want to standardize height, I want to keep it in, subtract mean and divided by standard deviation, right? We are going to deal rest of the story afterwards, this one. So let us study the graph of these two. Already I think we are having this graph. This is what it is. It is having a average of around 170, right? Now let me do the same thing for Z also. What is this? Mini 0. So here, what are these values? Z values. Before, what are these values? X values. All are with me. Things are clear or not? This is very, very important step which you need to understand. There is no concession. You need to understand. Friends, you guys understood what I've done? So this graph to moving from this graph to this graph is called standardization. I standardize the data. The process is called standardization, and this is also called a transformation. There are so many transformations which you are going to learn. So this is one of those. Okay. Statistically, this is called a what? Standardization. No need you to use the word transformation. That's okay. But you need to call this as a standardization only. Clear? Now, let me look at this. These two graphs are same. Here Z, here this is. You guys studied in 11th coordinate geometry. There is something called transformation of axis. You guys remember? Huh? This is simply application of that. But I'm not getting into the details of that. But what I'm trying to say is, this is just I'm shifting the origin. Okay? Okay. Let's not worry about what I said just before, but let us focus on this. So I want to find out the area between, what is the meaning of the area? Area between, let's say, 180 to this area I want. Okay, sir, understanding? I want to calculate this area along with P. So which is equivalent to, I will go and find out what is the corresponding Z value for 180 and what is the corresponding Z value for 192. What is that? Let us see. What is this? Z1 I am calling as a Z1. When x equal to how much? 180. Find out the Z value. I am calling as the Z1, or let's call Z180. How much is that value? X minus 180 minus mu. Mu is how much? 170 divided by 10. So how much is this? 10 divided by 10. This is 1. So corresponding to that is, this is a 1.2. So corresponding to that is around 1 here. 180 corresponding to 1, right? You guys are understanding what I'm saying, guys? Okay. Now Z. Another one is how much? 192. 190 or 192? Let's take 190. 190. So how much is this? 190 minus 170 divided by 10 only. So which is equivalent to 2. So I want, literally, what is the meaning of this? This is a 1 and this is around 2. I want to find out the between these two. Okay? Let me tell you, transformation of the area is not going to change. Area, look at the shape of the graph. Both are same, right? Whatever the area here, it is also same area. M and D. So finding out the area between 180 and 192. So what is the meaning of this is, I want to find out the area between 170 to 180 of f of x. What is the meaning of that? Sigma. Sigma is 10 root 2 pi e to the power of x. I'm going to write x afterwards. Mu is how much? 170 divided by, oh, not the 170, no? There's a 180 to 190, I believe, right? Yesterday we learned, if you want to find out the area, I need to integrate, right? Yes or no? Guys, so this is 10 square dx. You differentiate, but I don't know the difference. Sorry, you integrate, but I don't know the integration, how to do. So what these people have done, no, finding out this area is equivalent to finding out the, what is this? 1 to 2, because at 170, 180, my Z value is a 1 and this is 2. How much is this? 1 by sigma. Sigma is how much? For Z? 1? M and D? Sigma is 1, no? No? So instead of 10, I need to write 1 at 2 pi e to the power of here. What I need to keep? This entire thing will become what? Z, na? X minus mu by sigma. Z square. All with me. So when I have kept this Z. So this instead of ZX, I need to write the dz. So find out this area. This area is going to equivalent to this area. People who have not understood this, forget, no problem. But what statisticians done, they have evaluated this integral. Why? They evaluated this, they calculated this value, so which is equivalent to this value. Tomorrow you may be having 180, 190 as a height. If it is a kgs, I don't care. Still the area of this is not going to change, because it is going to have mean as 0, standard deviation as 1. So what statisticians done, as we don't know the calculus, they calculated and kept it. They calculated the areas. What they have done? They calculated different areas. What are those areas? Let me show that. So that you horoscope tables for us. What is this? These are the horoscope table. You gave me any data, I'll convert into this horoscope table. Don't call these a horoscope table. For your understanding, I'm calling as a horoscope tables. There is no word like a horoscope table. So you give any data, I'll convert my data into Z. I'll use this horoscope table. I'll repeat what I said. So for example, now I want to find out the area between, let's say, this 180 to 190, which is equivalent to finding out the area between what? 1 and 2. So here, these are the tables developed using mean as 0 and standard deviation as 1, and the data follows the normal, which is nothing but the Z for us. You guys are understanding? So no need to know your calculus. Still, they calculated and kept it ready. What is the meaning of that? They calculated and kept it ready. For example, what is the area between 1 and 2? So what is this? You see, what is the area they shaded? This is the area. Means what? For example, this is the 1, this is the 2. So this is the area between 1 and 2. All are with me. So always they have given the area between these two values. 0 to some Z value. 0 to some Z value they are given. So 0 to some Z value means what? Can I calculate like this? What the area I want? What they are given. So whenever you are using such horoscope tables, you need to look at what is the area they given in the table. So they are given this table. This is a 0 to Z value. But I want what now? Between the 1 to 2. So can I calculate Z equals to 0 to, I am going to calculate like this. First, it is going to give the area between, first time what I do, it is always this table, this table is giving the area from 0 to a particular value. Particular value could be 1 or 1, 2 or whatever it is. Okay. Let us look at this. Let's say this is 2. I am finding out what is the area I want. I want this part, right? Yes or no? This is a 1 and this is a 2. I want this part. But what is my table is giving? The area from 0 to 2 it is giving, and I can find out the area from 0 to 1 also. How I am going to get it? Let us see. Okay. Here some decimal values are there. Here some numbers are there. How we are going to look at? For example, 2, 1. 1 means what? 1.0? Yes or no? For example, if I want to find out the area from 0 to, let's say 0 to 1.23. How I am going to find out? First, look, this my table is going to give 0 to 1.23. Now, come this side. What is the value I can find out? What is the maximum value? In 1.23, what is the maximum value I can see? 1.2 here? Yes or no? And rest of the value, you see it here. If I add for 1.2, if I add the 0.03, that will become the 1.23. And where they are intersecting? This. So that area will 0.23. That area will become how much? Just before. 0.3907. So 39% is the area between 0 to 1.23. You guys understood now? So now, but I want to find out for our problem. I want to find out what? The area from 1 to 2. But table is giving 0 to 2 and 0 to 1 only. I can find out the 0 to 2 area. Let's go and find out. So 0 to 2. 0, 2. What is the maximum value I can look at here? 2. Yes or no? Let us look at 2. And I need to look at 2.0. 2.00 like that, right? So where I need to look at it? 2 means what? Here, this, I need to add this. M and D. Where they are intersecting. So this is the area. How much is this is area? So this green area, let me write in a green color. Green color is total green up to this. How much is this? 0.001. Okay, and what about this piece I want, right? Again, what about this piece? 0 to 1. How much is the 0 to 1? I'll go and look at where is my 0 to 1. 0.3413. 0.3413. All are with me. But what is the area I want? I want the area between 1 to 2. So can I subtract from this area to this area? Whatever I am going to get, that will become the area between 1 to 2, which is equivalent to area between 180 to 180. All are with me. So what I am trying to say is, if you do the calculations of this integral, how much I am going to get? The simplified answer. I am going to get 0.49 something. How much is that? 4772 minus 0.3413. So anyway, they simplified and kept it ready, but always they assume mean as 0 and standard deviation as 1, because they cannot do every time with a change in mean and different mean and sigma square values, right? So you take any data, if it is following the normal, it is going to, if you calculate the Z, it is always going to have 0 mean and standard deviation as 1. So they prepared the table based on that. All are with me. So tomorrow you get any data, what I'm going to do, I calculate the Z value. If that data follows the normal, if I want to calculate the probability, find out the area between these values. So that will become your probability. All are with me. All are with me. So simplified. This is a simplified. No need you to know this integration, but still you are using directly from the tables. This whatever the simplification you have done, whatever the answer you are going to get it here. This is equivalent to this. All are with me. So that's the reason I said no need to know the integration. They simplified and they kept it ready. I think yesterday class you connected today. Huh? You guys connected today? Friends? Without teaching that integration part, if I teach directly, you may not understand. Hope this is clear to everyone. Okay?